बिस्मिल्लाहिर्रहमानिर्रहीम। अल्लाहुम्मा सल्लि अला मुहम्मदिन व अला आलि मुहम्मदिन व बारिक व सल्लिम। रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वहलुल उक़्दतम मिन लिसानी यफ़क़हू क़ौली। Assalamu alaikum. I am Dr. Omar Farooq. So, students, in lecture number 1, we talked about chemistry, matter, and structure of atom, and the terms related to an atom like atomic number, mass number, and isotopes. In lecture 2, particles of matter were discussed, such as atom, ion, molecule, and formula unit. In lecture number 3, we studied various types of matter, such as substance, element, compound, and mixture. And in the last lecture, that is lecture number 4, I tried to explain the representation of particles of matter, that is atomic symbols, empirical, molecular, and ionic formulae. Today's lecture is about the masses of these particles. Mass of an atom is called atomic mass. Mass of a molecule is called molecular mass. Mass of a formula unit is called formula mass, and the mass of an ion is called ionic mass. So first in the list is atomic mass. But before this, I want to recall some basic terms from my first lecture, that is atomic number, mass number, and isotopes. Atomic number Z of an element is the number of protons in the nucleus of each atom of that element, whereas mass number A is the number of protons and neutrons in the nucleus of an atom. For example, carbon has 6 protons, oxygen has 8, phosphorus has 15. So the atomic number of carbon is 6, oxygen is 8, phosphorus is 15. There are 6 neutrons in the most abundant isotope of carbon, 8 in oxygen, and 16 in phosphorus. Since the mass number is the sum of protons and neutrons, so the mass number of carbon is 6 plus 6 equals 12. Mass number of oxygen is 8 plus 8, that is 16. And the mass number of phosphorus is 15 plus 16 is 31. Isotopes are the atoms of an element which have same atomic number but different mass number. For example, hydrogen has 3 isotopes, hydrogen 1, hydrogen 2, and hydrogen 3. They are given the names protium, deuterium, and tritium respectively. Carbon also has 3 isotopes, C12, C13, and C14. There are 2 isotopes of chlorine, chlorine 35 and chlorine 37. Remember students, mass number and atomic mass are different terms. Let me clarify with the help of following example. Hydrogen has 3 isotopes, that is protium, deuterium, and tritium. Each isotope has 1 proton, but there is no neutron in protium, 1 in deuterium, and 2 neutrons in tritium. Their nuclei look like this: 1 proton only, 1 proton and 1 neutron, 1 proton and 2 neutrons. So their mass numbers are 1, 2, and 3 respectively. Their percentage abundance in nature is very different from one another. More than 99.9% hydrogen consists of its isotope protium. Deuterium is in 0.015%, that is, out of 1 lakh atoms of hydrogen, we have only 15 atoms of deuterium, whereas tritium is in traces. Note that masses of isotopes vary due to varying number of neutrons. As far as atomic mass of hydrogen is concerned, it is neither 1 nor 2 or 3, Rather, it is 1.008, which is very close to the mass number of protium due to its highest abundance. Actually, atomic mass of an element is the average mass of all of its naturally occurring isotopes compared with C12. This is to be noted that mass number is a whole number, whereas atomic mass is in fraction. One more thing is notable, that mass number is an absolute quantity, whereas atomic mass is a relative quantity. I'm repeating this. Mass number is an absolute quantity, whereas atomic mass is a relative quantity. To understand the term atomic mass, let me first clarify the difference between relative and absolute quantities. On the basis of ways of measurement, physical quantities are of two types: absolute and relative. Absolute quantities are those quantities which do not need any reference for their measurements, whereas relative quantities need some reference for their measurements. Moreover, relative quantities are determined by comparing with a standard, while absolute quantities are not determined by comparison method. This is to be noted that the comparison is made either by taking difference or by taking ratio with the standard. I'll now explain these terms by some examples. So the first example is relative speed. Let there are two cars A and B moving in the same direction with different speeds. Suppose the speed of car A is 60 km per hour and that of car B is 40 km per hour as shown by their speedometers. So these are their individual speeds. That's why called absolute speeds. But if we compare their speeds with respect to each other, we get their relative speeds. The comparison is made either by taking difference or by taking ratio with the standard. So, relative speed of car A means that car A is moving with a speed of 20 km per hour faster than car B. If we find their ratio, we say that relative speed of car A is 1.5 times that of speed of car B. In this case, car B is chosen as standard. Likewise, you can find the relative speed of car B in comparison to car A by taking difference or by taking ratio. So, speed of car A is chosen as standard in this case. Another example is relative age. Let X, Y and Z be three brothers having ages 15, 13 and 9 years respectively. These are of course their absolute ages. Let us now find their relative ages with respect to one another. So, if we select X as standard, then relative ages of Y and Z are described as Y is 2 years younger than X and Z is 6 years younger than X respectively. In the same way, if Y is chosen as standard, then relative ages of X and Z are X is 2 years older than Y and Z is 4 years younger than Y respectively. Similarly, we can find the relative ages of X and Y with respect to Z. So by these two examples, we conclude that we can choose anything or anyone as standard. While studying kinematics, you cannot define rest and motion of a body without comparing its state with its surroundings. So, rest and motion both are relative terms, as Einstein described in his famous theory of relativity. all motions are relative motions. That is, there is no absolute motion in the universe. The masses of atoms are in the range of 10 raised to the power minus 24 to 10 raised to the power minus 22 gram. That is from this to this. So, we cannot weigh such an extremely small mass with the help of any sensitive balance. To resolve this problem, scientists devised a comparison method for such measurements. Due to stability and abundance of carbon compounds, carbon is used as standard reference. Therefore, mass of any atom is compared with carbon-12 scale. That's why we add the word relative with the term of atomic mass, that is, relative atomic mass. On this scale, relative atomic mass of C12 is considered exactly as 12.0000. So, atomic mass is a relative quantity because it is obtained by comparison method. The comparison is made with a standard. C12 isotope is used as standard. Let us define atomic mass again. Atomic mass of an element is the average of all the naturally occurring isotopes of that element compared with C12. For example, isotopes of hydrogen have different mass numbers, but their average atomic mass compared with C12 is 1.008. Relative atomic mass can also be defined as follows. The average mass of the atoms of an element compared with 1/12 the mass of an atom of carbon-12 isotope is called relative atomic mass. The unit of atomic mass is atomic mass unit, abbreviated as AMU, which is 1/12 the mass of carbon-12. Let this rectangle be the carbon-12 atom, and we divide it into 12 equal parts. So each fraction has a mass of 1/12 of the whole atom, and each of these 1/12 fractions represents 1 AMU, that is 1/12 the mass of carbon-12 atom is equivalent to 1 AMU. On this scale, relative atomic mass of carbon-12 is exactly 12.0 AMU. This is the relation between AMU and gram. How do we find the average atomic mass of an element? This is explained with the help of an example. A sample of chlorine is found to consist of Cl35 and Cl37 in the percentages 75.78 and 24.22% respectively. Calculate the average atomic mass of chlorine. To solve this problem, first multiply the mass of each isotope of chlorine by its abundance and then add the resulting quantities. And finally, divide the sum by 100 to get 35.48 AMU, which is rounded off to 35.5 AMU. Let me now elaborate these calculations. Let's count these spheres. 1, 2, 3, 4, 5, 10, 20, 25, 50, 75, 100. Suppose these are 100 atoms of chlorine, out of which 75 atoms are chlorine 35 isotopes, while 25 atoms are chlorine 37 isotopes. I have made a little change in the percentage abundance of each isotope just to draw a symmetrical diagram. Now, mass of 75 atoms of chlorine at the rate of 35 per atom is equal to 75 into 35, and Mass of 25 atoms of chlorine at the rate of 37 per atom is equal to 25 into 37. So total mass of 100 atoms of chlorine is equal to the sum of these two products, which is 3550. So the average atomic mass of chlorine is obtained by dividing this sum by 100, which gives 35.5 AMU. This is the average atomic mass of chlorine. Atomic masses of some common elements are given in this table. Students must try to learn them by heart. The unit of these masses is, of course, AMU. One thing to be noted is that the atomic mass of hydrogen can be rounded off to 1. But atomic mass of chlorine and copper must be used as such in the mathematical calculations. So this was all about atomic mass. Next in the list we have molecular mass and formula mass. We'll study them together as I taught molecular formula and empirical formula together. Molecular or formula mass of a compound is actually the mass of a particle of a compound, and the mass of one particle of a compound is measured by comparing its mass with 1/12 the mass of an atom of carbon-12 isotope. On the next slide, I'll give its simple definition. As you know that there are two types of particles of compounds. They are a molecule or formula unit. So there are two types of masses of compounds. If a compound consists of molecules, its mass is called molecular mass. And if a compound consists of formula units, its mass is expressed as formula mass. In the word molecular, AR means of one or of a. So molecular mass represents mass of a molecule, and formula mass is the mass of a formula unit. Both are expressed in AMU. According to your textbook, molecular mass is the sum of the atomic masses of all the atoms present in one molecule of a molecular substance, whereas formula mass is the sum of atomic masses of all the atoms present in one formula unit of a substance. To determine the molecular mass of a compound, focus on this example. Calculate the molecular mass of nitric acid, HNO3. To solve this problem, we first write atomic masses of all the elements. So atomic mass of hydrogen is 1, atomic mass of nitrogen is 14, and atomic mass of oxygen is 16, all in AMU. So molecular mass of HNO3 is atomic mass of hydrogen plus atomic mass of nitrogen plus 3 times the atomic mass of oxygen, because there are 3 atoms of oxygen in one molecule of HNO3. So putting their values, we get the molecular mass of HNO3, that is 63 AMU. To find the formula mass of a compound, consider the following example. Calculate the formula mass of potassium sulfate, K2SO4. To solve this problem, we first write the atomic masses of all the elements. Atomic mass of potassium is 39, atomic mass of sulfur is 32, and atomic mass of oxygen is 16. All in AMU, of course. So formula mass of potassium sulfate is 2 times the atomic mass of potassium. The atomic mass of sulfur comes only once, and 4 times the atomic mass of oxygen. Putting their values and simplifying, we get the formula mass of potassium sulfate is 174 AMU. So we have come to the last topic of our today's lecture, that is ionic mass. The term ionic mass is not included in syllabus. I'm describing it just for understanding. So mass of an ion is measured by comparing its mass with 1/12 the mass of C12 isotope, or in simple words, ionic mass is the sum of atomic masses of all the atoms present in one ion. In the word ionic, IC means of one or of n. So, ionic mass means mass of an ion. It is also expressed in AMU. To determine the ionic mass of an ion, consider the following example. Calculate the ionic mass of sulfate ion, SO4 2 negative. So, to solve this, we first write the atomic mass of sulfur, that is 32 AMU. Atomic mass of oxygen is 16 AMU. Therefore, ionic mass of sulfate is atomic mass of sulfur plus 4 times the atomic mass of oxygen. Substituting their values and simplifying, we get ionic mass of sulfate equals 96 AMU. The smallest unit of an element or a compound, if exists freely, is called molecule, and if it does not, for an element it is called an atom, for a compound it is called formula unit. Mass of an atom is called atomic mass. Mass of a molecule is called molecular mass, whether the molecule belongs to an element or a compound. And the mass of formula unit is called formula mass. All of these masses are expressed in AMU. If you have any question, please do write in the comments below.